Circle theorems. So I've been asked to create a video summarising the different circle theorems and then how you would go about answering a circle theorem question in an exam. So we'll start off straight away. There are 7 main circle theorems that you need to know, ranging from quite a simple one to more difficult one. I'm not going to prove them. If you're interested, you can find the proof. I believe BBC Bite-Size does a good explanation as to why the circle theorems are what they are. So let's jump straight in. If I have a circle, we've got our center point and a radius, and then I'm going to draw a tangent that meets the circle at the point where the radius does. The first circle theorem says that the tangent and the radius meet at 90 degrees. So the tangent and radius meet at 90 degrees. And that's our simplest theorem. So that is number 1. Number 2. Now, again, we've got our circle, and this time we're going to draw a quadrilateral inside the circle. So this is a cyclic quadrilateral, which means that all 4 corners are on the circumference of the circle, and it is entirely within the circle. Now, the theorem states that opposite angles, so let's call this one A and this one B, it says that opposite angles in a cyclic quadrilateral add up to 180 degrees. So in this example, I'll put this in different colour. A plus B is 180. 180, here we go. And let's call these C and D. C plus D is 180 degrees. So this could be very useful if you get a question and you need to find different angles, but you can see that there is a cyclic quadrilateral there, then you can use this theorem. Moving on to what I believe is the most important circle theorems. This is number 3, and this time we have more of an arrowhead shape. So we need our center point, which is there, and we're going to have a pair of radii. So we've got 2 chords, there and one there, and then 2 radii, which meet obviously at the center. So this theorem states that the angle at the center, which is this angle here, which we're going to call A, so the angle at the center is twice the angle at the circumference. So this angle here, so this is, let's call this 2A then, and that is A. So the angle at the center is twice the angle at the circumference. This leads very closely to the next theorem. I'm going to leave that one up there, number 4. This time we're going to have center point. So we're going to have a diameter that is going through the center point there. And this time we're going to turn the diameter into one side of a triangle. So if we have a look here, we could say that this being a diameter, it's a straight line, so the angle at the center is 180 degrees. Using theorem 3, which states that the angle at the center is twice the angle at the circumference, we can say that the angle at the circumference is 90 degrees. Half of 180, 90. So the angle in a semicircle is a right angle. This obviously does not mean this angle here or this angle here. It does mean the one opposite the centre. Okay, so moving down, number 5. So now we're going to have a look at, let's put our centre point in. There we go. Okay, so we're going to draw chord. I'm actually going to use a different colour in the next few. I'm going to have a point over here. Oops. That should be meeting at the circumference there. The darker blue. So as you can see, I've got 2 pairs of chords. None of them go through the centre. They probably could, but that would be a special case. So this angle here, let's call it A. And this theorem states that angles in the same segment are equal. So angles in the same segment are equal. So by that we can say that this angle here is A. The key point to notice here is that both the dark and blue line, they meet here and they meet here on the circumference. A very key point. If they don't meet, so let's say that the light blue came down here and the dark blue is remaining in its place over here, then we wouldn't be able to use this theorem. Okay, so angles in the same segment are equal. Now we're going back to having a look at a tangent. So number 6, draw a nice circle. This time we're going to have 2 tangents. So I'm going to draw a tangent along this point and a tangent that goes across. Oops, let's pretend that meets there. So they meet at the point, let's call it A. Let's call this one B and this point C, where it meets the circumference of the circle. So tangents that meet at the same point, so the same point A, are equal in length. So that means that AB is equal to AC. So tangents that meet at the same point are equal in length. Right, now moving on, we have one final theorem to have a look at, and this one even has its own name, the alternate segment theorem. Okay, so once again we've got a circle, we've got a tangent which is meeting at, let's say, this point here. It's not the best drawing, and then within this we have a triangle. All of the vertices of the triangle are on the circumference of the circle. This one is at the point where the tangent meets the circle also. I'm going to call this angle here between this chord and the tangent A. The alternate segment theorem says that the angle between the tangent and the chord is equal to the angle in the alternate segment. Angle in the alternate segment. So what does that mean? Well, that means that this angle here is also equal to A. So that should be just between the blue lines. So again, just to make sure it's clear. There we go. Now, of course, with this particular diagram, we can do this again. So the angle between the tangent and the chord, let's use this chord here this time. So between the tangent and the chord, let's call that B, is equal to the angle in the alternate segment. Well, that would be that angle there. So we can find out quite a lot of information just from our circumference. So let's go back and have a quick summary. Moving back up. So the tangent and the radius meet at 90 degrees. In a cyclic quadrilateral, opposite angles add up to 180 degrees. The angle at the centre is twice the angle at the circumference. The angle in a semicircle is a right angle. Angles in the same segment are equal. Tangents that meet at the same point are equal in length. And the alternate segment theorem, which says the angle between the tangent and the chord is equal to the angle in the alternate segment. So now I'm going to show you how we can use this. So I have taken a standard, I believe this is a 4-mark exam question from, and I think it was an Excel paper as well. Not that that matters, it's on the higher GCSE. So we've got a circle and we've got a load of chords. So A, B, C and D are points on the circumference of a circle. Angle ABD is 54 degrees as marked, and BAC is 28 degrees as marked. We want to find the sides of the angle ACD. So let's mark that on, ACD, which I'm going to call X, because that's our aim. And we also get marks for giving a reason for our answer. Now, how do we formulate our answer? There is a very easy framework to do this. If this, then this, because this. And if you follow that method, you'll get full marks every time using the correct theorem, obviously. So for this one, we've got a pair of lines here, and we have a pair of lines here. So if we're able to go back to Theorem 5, we can see that angles in the same segment are equal. So let's remember that. Let's go back to the question. So angles in the same segment, 54, and X makes 54. Don't forget, always write the answer on the answer line. An examiner is not going to just wander around your page looking for answers. If you can't find it, you won't get the marks. So how do we explain this for part 2? If angle ABD, notice the if coming in there, is 54 degrees, then angle ACD is 54 degrees because angles in the same segment are equal. So by following on this if then because, we have been able to formulate an answer that gives full reasoning, and an examiner or marker can see exactly where you have got your information from. So you've used the fact that angle ABD is 54 degrees. You have concluded that because of this, angle ACD is 54 because of this theorem. I hope you found this useful. Thank you for watching. Don't forget to subscribe or like, and keep me infused to create more videos. Thank you very much.